we have started lecture series on JEE Advanced previous year question paper. I already explained plenty of the videos on my channel, which completely based on JEE Advanced. Not only JEE Advanced, but we have started MST CET Mathematics, JEE Mains, and other competitive exams too. So, in our today JEE Advanced question, we are going to learn one of the question which is from the complex analysis. So it is quite little higher concept over there. So we have to find out the argument in our question. Okay. Now let's get start our question. Let's read the question. So what we have given in our question. So in our question, we have given S be the set of a complex number. Okay. S is a complete set of a complex number, and S is represented as S such that S which like as a modulus of a Z minus 2 plus I which greater equal 5. Okay, so this is the equation of S which S represent. Okay, so it seems like that this is the equation of a circle. Okay, in a complex form, and we have given 1 upon Z naught minus 1 is a maximum. Okay, so we have given 1 upon Z naught minus 1 is a maximum in a question, and we have to find out argument of 4 minus Z naught minus Z naught bar upon Z naught minus Z naught bar plus 2i. So Z naught bar which represent here, it is a complex conjugate of a Z naught. So complex conjugate of a Z naught, it represented by Z naught bar. Okay. So by using the quantity of 4 minus Z naught bar upon Z naught minus Z naught bar plus 2i, we have to find out its argument. Okay. So we have given 4 options and we have to figure it out which one of the option is correct. Okay, now let's get started our today's solution. I will explain our today's example in detail. Okay, so it is quite easy example, but little bit lengthy. So let's get to see our today's solution. In our solution, we have given S is a set of a complex number. Okay, such that S look like modulus of a Z minus 2 plus I which greater equal 5. Okay, so this is the equation of a S which S represented. So it seems like that this is a quite familiar equation of a circle which is in a complex plane. In a complex plane, equation of a circle like a Z minus Z naught which is equal to R. So this is the equation of a circle in a complex plane. And in a real plane, we know that x square plus y square which is equal to R square. In a complex plane, this one is the equation of a circle. So compare our given S with our standard equation of a circle. Okay, and which represent that standard equation. Z naught is the center here and R is the radii. Okay, so that one I explained here, which is the equation of a circle in a complex plane, that is a Z minus Z naught which is equal to radius. Okay, so R here radius and Z naught is a center. So we want the value for argument. Okay, and argument is we know involve Z naught. Okay, Z naught means in a complex plane we write Z as a x plus iy. So Z naught is a x naught plus I times y naught. Okay, so that means we want the value for x naught y naught here. Okay, so if we come to know the value for x naught y naught, then it is easier to find out the value for Z naught, and our argument it completely involved with the values of Z naught. Okay, so let us see. First of all, we will find out the value for Z naught. So Z naught means we have one point which is Z naught as a x naught y naught. Okay, this is the coordinate for Z naught. Okay, so how it is coming? Z naught can be written as x naught plus I times y naught. Okay, so Z naught can be written as x naught plus I times y naught. So coordinate of Z naught we write as the first coordinate of x and second coordinate of y. Okay, so these are the coordinate from the complex plane. So Z naught is a x naught y naught. Okay, now in our equation we have given Z minus 2 plus I under modulus greater equal 5. Okay, so compare it Z which is equal to as it is, and my negative of Z naught which is equal to, take the negative sign common from here. So how it look like? So Z minus, take negative sign common from 2 plus I. So under bracket it will remain 2 minus I. Okay, so modulus complete which is equal to, we write it as the 5. Okay, for few minutes we will write that inequality as a equal sign. Okay, so we can see it here, Z as it is here minus of a Z naught which is equal to radius. So Z naught it is here 2 minus I. So I got the coordinate for Z naught. Okay, which is the center. So that Z naught in our question we have given that Z naught and this Z naught both are different. Don't get confused. Huh? in our question we have given z0 as x naught plus I times y naught. So this z0 I consider as a different variable. So that z0 I got it here to minus I. That means it is not the value for our z0 in argument. Okay, so that value is a different. Okay, so this is the just representation here for a center. So z0 is equal to x naught plus I times y naught. This is the our value actually we need it in our argument. So here by using this I got the center z0 is a 2 minus I. So you may consider it as the y naught, p naught, something there. Okay, so not that values are getting crashed. Okay, so z0 I got it is here 2 minus I, which is the center of our circle, and the radius of our circle is a 5. And if we write their x and y coordinate, x is a 2 here and y is a negative of 1. Okay, so x 2, y negative 1, and radius is 5. So center of our circle 2 negative 1, radius is a 5. Okay, and one more condition we have here, the given 1 upon z0 minus 1 is a maximum. 1 upon z0 minus 1 is a maximum. Then can we write z0 minus 1 as a minimum? Okay, so if I write 1 upon minus 5, this contain maximum value. Okay, it has a maximum value. Okay, that means this one is a smaller value than negative 5. So negative 5 is bigger and this one is smaller. So if this is having maximum value, then we write this one is a only negative 5 is a minimum value. Okay, so obviously it holds this. If this is a maximum value, so negative 5 is a minimum value. Okay, so this is the suitable example just to understand 1 upon z0 minus 1 is maximum, then z0 minus 1 why it is minimum. Okay, so if 1 upon minus 5 is a maximum, then minus 5 is a minimum, or 1 upon 5 is a mag, or you may go to some other way, other example. Okay, that 5 is a maximum or 5 is a maximum, then we write 1 upon 5 is a minimum. Okay, so these are the vice versa example to understand this one. Okay, so z0 minus 1 is a minimum. Okay, so which is having minimum value. So again we can see that z0 minus 1 is a minimum, so which represent equation of a circle again, which is again equation of a circle, z minus z0. Okay, but radius did not mention here. Okay, so we do not have to worry about radius, just find out the center from our equation of a next circle. Okay, in a complex plane. So z0 minus 1 is a minimum. Okay, so we can see that here z minus z0, that means here we have the next point which at a center at a 1. Okay, that means 1 means 1 plus 0i. Okay, 1 can be written in the form of a complex as a 1 plus 0i, because every real number which belongs to the complex number. Okay, so that 1 is a real number, we can write it in the form of a complex as 1 plus 0i. Okay, so this is the 1 plus 0i, it is a center here. So again we can see the coordinate for that point is x1 y0. Okay, and third point we know that z0 is x0 plus I times y naught. Okay, so that one is in our claim. What we have claimed here, we want the 4 minus z0 bar. So z0 it is there in our argument, so that z0 I taken here now, that z0 is x0 plus I times y naught. Okay, so coordinate of a z0 is x0 y naught. So by using our given information, I got the value for coordinate of a z0, the coordinate of a z0 minus 1, and the coordinate of a modulus of a z minus 2 plus I. Okay, I got the 3 coordinate by using this 3 form equation under complex plane. Okay, and one more condition, that is we have given z0 belongs to S with z0 minus 1 as a minimum value at a point on boundary of a circle of a region S, which lies on a radius of a circle and passes through 1 0. Okay, so meaning for this, we have these 3 points not perpendicular to each other, they are not crossing to each other. Okay, so if they are not crossing to each other, that means they are collinear. Okay, so what is meant by collinear points? So if I consider these 2 points or 2 lines, okay, these are the 2 lines which is a parallel to each other, so we say that these 2 lines are collinear. Or if I draw one more line again here, A B C, so line AB is a and line BC. Okay, AB and BC are collinear line, they are along line, that's why they are collinear. Or this line and this line, this is also collinear because they are parallel. When we have parallel line, we say that these are the collinear line. Okay, so when we have parallel line or perpendicular line, so exactly this is the condition given. So we have 3 of these points. Okay, z0 1 2 minus I, all these are the collinear. Okay, collinear means they are not perpendicular to each other. So if you wanted to see, you may plot these points 1 0 at a center area, at a radius of 5 at a point 2 minus 1. Okay, so you plot these points, try to draw the graph. Okay, you will come to see. Okay, so I'll show the graph here in next slide. So here next we have 3 points are collinear. That means they're not having x naught y naught coordinate. One is having x coordinate 1, y coordinate 0. That means 1 plus 0 I, second coordinate. Third coordinate 2 minus I. Okay, that means x2 y minus 1. All of 3 of these are collinear. Okay, so if 3 of these are collinear, that means they are parallel or along lines. And when we have parallel lines, 2 or more than 2 parallel lines, then we write their slope as a y2 minus y1 upon x2 minus x1, or y minus y1 upon x minus x1. Okay, so this is the way to write the parallel slope of parallel line. So I written over here slope of, so this one is a basic concept you need to know. So if you are trying to solve the question from JEE Advanced, you need to know all the basic concept from your textbooks. Okay, so if the lines are parallel, then that means how we write their slope. Okay, so their slope can be written as y naught minus 0, so y2 minus y1 upon x naught minus x1, which is equal to next point. So negative 1 minus 0 upon 2 minus 1. So these are the coordinate for two parallel lines. Okay, so these are the coordinate. So try to solve this one further. So y naught minus 0, which remain y naught upon x naught minus 1 upon negative 1 upon 1. Okay, so which is a negative 1. So y naught, which is equal to x naught minus 1, take it here, and negative sign it come from here. So 1 minus x naught. So these are the just basic calculation. I hope you have understood this one. Okay, so now our main claim is here. Okay, now main solution, it will start from here. Okay, so all are the given data from our question. I explain it here. Okay, now from now onward, we are going to solve our main solution of our example. Okay, that we found the given by using our given data. Okay, so these all given values which is I constructed by using our given information. So now claim we want the argument of 4 minus z naught minus z naught bar, z naught minus z naught bar plus 2i. Okay, now if z naught I can write as a x plus iy. Okay, if z naught is x plus iy, so conjugate of z naught, that means z naught bar, can be written as x minus iy. Always remember, when we write the conjugate, we take opposite sign of this iota only. The term it is from imaginary, the conjugate effect only on that term. Okay, so 4 minus z naught bar, so take it into the simplest form. So negative sign common here, 4 minus z naught plus z naught bar upon z naught minus z naught bar plus 2i. Okay, as it is here. So 4 it is here. Z naught can be written as x naught plus I naught, I times y naught. Okay, and z naught bar x naught minus I times y naught. So as I explained earlier here. Okay, so z naught is x naught plus I times y naught minus z naught bar is x naught minus I times y naught. Okay, plus 2 times I. Okay, so this is the expanded form of these two terms here. Now go for further calculations. So what we have possible to cancel, plus I times y naught minus I times y naught, cancel. X naught plus x naught, 2 times x naught. So 4 minus 2 times x naught. Okay, it is here. So x naught plus I times y naught minus x naught plus I times y naught. Okay, so plus x naught minus x naught get cancelled, plus I times y naught minus minus plus I times y naught, 2 times I times y naught and plus 2i as it is here. Okay, so 4 times 2 times x naught, 4 minus 2 times x naught as it is here, 2 times I times y naught plus 2i, take 2i common here, so 2i common here, so 1 minus x naught plus, so what we have here, 2 times I times y naught plus 2i. Okay, so y naught having value, I got it the value for y naught, it is 1 minus x naught. Okay, earlier I found this one. So y naught is 1 minus x naught. So y naught 1 minus x naught I substitute here. Why we have to substitute the value for y naught here? Because when we have any equation, whether it is in the form of x or y, okay, so we have to reduce this equation in the form of x only or y only. So it is easier to find out their corresponding values then. Okay, so try to reduce their two values into the one value. Okay, so this variable need to be into the form of 1. So x naught here, y naught here, whether reduce x naught or y naught. Okay, so we have x naught value here as well as y naught. So as I felt y naught is suitable here, so I substitute the value for y naught. So 2i y naught it is here 1 minus x naught plus 2i here. Okay, so 4 minus 2 times x naught, so 2i minus 2 times x naught plus 2i. So 2i plus 2i 4i, and 2i plus 2i is a 4i, 2 times I times x naught as it is here. Okay, so here in my next step we can see 4 minus 2 times x naught upon 4i minus 2i x naught, we got it here. So take 2 common from here. Okay, or no need to take 2 common, try to make numerator denominator same. Take 1 upon I common here, so 1 upon I common here, 4 minus 2 times x naught and 4 minus 2 times x naught. Okay, this one get cancelled with this one, so we land on only the value for negative of iota. Now see that in our question we have given argument of a little complex quantity, but in actual if we solve that quantity, see we land on only negative of iota. Okay, so that means argument of that complex quantity means we want the argument of a negative of iota. Okay, so after solving that value I got the negative of iota. Okay, so we want the argument of a negative of iota. Now for finding the argument of any complex number, we know that we use, when we have xy as order pair, we use tan theta as a tan inverse y by x. Okay, when we have xy order pair, like if I have xy as an order pair here, so then for finding its argument we write tan inverse y by x. Okay, so this is the argument for finding the result of argument, standard result that we use here. So argument of a negative of I, it can be written as argument of a 0 minus I. Okay, so we need in the form of xy order pair. Okay, so we can generate the value for x is a 0 and y is a negative 1. Okay, by using this one. So that means x0 here and imaginary part is negative 1. Okay, so I got the x0, y is a 1. So argument of a theta can be written as tan inverse of y by x. Okay, so tan inverse of a negative 1, so y is a negative 1 here, x is a 0 here. Okay, tan inverse of negative 1 upon 0. So tan inverse of something upon 0 is infinity, but negative sign, so negative infinity. Tan inverse of negative infinity, so we know that tan of negative pi by 2 is a tan negative infinity. Okay, so take that negative out from here, so it will out here. So tan inverse tan, these are the inverse and trigonometric functions, so we left only the value with a pi by 2. Okay, so our required value, which is here, argument of a negative I, which is equal to negative pi by 2. But the argument of a negative I, the value of argument of a negative I, which is coming from our complex quantity, which is given in our question, that 4 minus z naught minus z naught bar upon z naught minus z naught bar plus 2i. Okay, so the value after solving I got it here, negative of I. Okay, so the argument of a negative of I found it here. Okay, now see that how easy solution it is. Just first of all, what we have to do, we have to construct what we have given in our question. Try to understand, try to write all this concept in a plain paper and try to apply the concept which you know. Okay, so on what way you can solve these concepts. Okay, so there are plenty other way to solve this question, but as I feel that this one is easier to understand, so I explain this to you all as per my best. So even after, if you do have any doubt, difficulty, let me know in comment section. Okay, so I explained here one of the question from JEE advanced previous year question paper. As you all can see, these questions are quite a bit application based question and little higher level questions. Okay, but not that difficult, you may easily solve these questions. Okay, so I hope so you all have understood my today's solution. So thank you everyone, thank you for my today's solution.